Okay, so good morning, everyone. Our topic for today is about alcohols and phenols. Okay, so we are very already familiar with the chemical structure of alcohol and phenol. So any chemical compound that has an OH functionality is an alcohol. So if the OH is bonded to a benzene ring, we have the phenol as well. And then if the carbon uh, next to the OH functionality is in double bond, we have enol. So the very famous example of alcohol is methanol, CH3OH, also called as methyl alcohol. So the methanol was prepared by heating wood in the absence of air. That's why another term for methanol is wood alcohol. And it's already been known to be toxic to human, and it can cause blindness even in small doses and death if intaken in large amounts. Another example is ethanol, CH3CH2OH, or also known as ethyl alcohol. So this ethanol is the first organic chemical to be prepared and purified, and its production is via fermentation of grains and sugars. And the process has already been carried out 9,000 years ago. Even its purification via distillation, it's already been um, utilized in the 12th century. So, yung ethanol is a very old process na talaga siya. Very old um, chemical. And nowadays, it's been the production is via the fermentation of corn, barley, and other plant resources. So another example is the phenol, so or also known as phenyl alcohol. So phenol is occurring already widely throughout even nature, and it serves as well as an intermediate in industrial synthesis of products such as adhesives and antiseptics. So phenol is found in coal tar also. So note that the phenol is the name. It's not called as hydroxybenzene, but it's phenol. In naming alcohols and phenols, we have um we classify them as three. So we have the primary alcohol, in which only one R group is bonded to the central carbon. And then we have the secondary alcohol. Two R groups are already present in your alcohol. And then the tertiary. So three R groups are already present in your alcohol. So the number of organic groups bonded in the hydroxyl bearing carbon. So it depends on the number of organic groups. So if walang R group na nakabond sa carbon mo, so it's methyl. If tatlong hydrogen lang. So take note of this. And for naming alcohols, so there are three rules. And you need to remember that the last letters for alcohol is OL. So replace the E in alkane to ol. So the first one is the usual. You need to select the longest carbon chain. Select the longest carbon chain containing the hydroxyl group and derive the parent name by replacing the E ending of the corresponding alkane with OL. So you have, for example, this one, 1, 2, 3, 4, 5. So pent. So you have two since the methyl group is bonded to the second carbon. So 2 methyl, 2 since the al or hydroxyl group is bonded to the second carbon. So 2 methyl, 2 pentanol or 2 methyl pentan 2 ol. And the second rule, number the alkane chain beginning at the end nearer the hydroxyl group. So doon ka mag-start mag-count kung saan yung OH mo yung pinakamalapit. So in this case, dito ka mag-start, not here sa fifth carbon. So here, because OH is near at this carbon. And last rule is number the substituents according to their position on the chain and write the name listing the substituents in alphabetical order. So this is also the usual rule in naming organic compounds. So alphabetical order and identify the position to which the OH is bonded. So for example, in naming this compound here, so 1, 2, 3, 4. So you have 1, 4. So remember, cis siya because the hydroxyl group are on the same side. So cis 1, 4, cyclohexane diol. So di kasi dalawa yung hydroxyl group mo. Or cis cyclohexane 1,4-diol. And then another one. So yung substituent mo dito is phenyl. So yung phenyl naman is nasa third carbon mo kasi nag-start ka mag-count doon sa carbon kung saan yung pinakamalapit yung hydroxyl group. So 1, 2, 3, 4. So 3 phenyl, 2 butanol or 3 phenylbutanol. So again, remember to use phenol as the parent hydrocarbon name and not benzene. So this is phenylmethanol. And then for allyl alcohol or for yung may double bond, so 1, 2, 3. So 2, since the double bond is on the second carbon. So 2 propen, 1, since yung alcohol mo is nasa first carbon mo. So 2 propen, 1 ol. And then this one, 1, 2, 3. So prop. So 1, 2, 3, 2 methyl 2 propanol. And here we have, this is an ethylene glycol or 1, 2 ethane di, dalawa yung hydroxyl group ol. And then this is glycerol or 1, 2, 3, 1, 2, 3 propane triol. So let's go to the properties of alcohol. So the ROH bond angle of the alcohol, it is like water, it is tetrahedral in structure. So this is methanol, tetrahedral din yung structure niya. Like water, kasi yung oxygen mo dito is may double bond, ay may lone pair pa siya dito. Dalawang lone pair. Kaya tetrahedral yung shape niya. And yung angle from your hydrogen, oxygen to your carbon in the ROH bond or yung alcohol mo is 108.5 yung bond angle niya. And it is sp3 hybridized. Just like water din, mataas yung boiling points niya because of yung alcohol is hydrogen bonding siya. So meaning pag hydrogen bonding, may polarization na mangyayari. Dito na part, dito sa may red na part, this is negative, partially negative charge. And then dito naman sa hydrogen mo na part, this is partially positively charged. So yung hydrogen mo, there's a tendency that it can attract to the lone pair of other alcohol compound. So that's the bonding nila between an alcohol to the other alcohol is hydrogen bonding, just like water. So the weak force that holds the molecules together in that holds the alcohol molecules together is hydrogen bonding. And then another similarity with water is that alcohol and phenols have weak acts as a weak base and acid. So as weak bases, they are reversibly protonated by a strong acid. So if yung alcohol mo ipareact mo with strong acid, they yield an oxonium ion. This is oxonium ion or ROH2. Okay. So this alcohol, it will act as a weak base if being reacted with a strong acid. And then like water din, yung alcohol din, they also act as a weak acid. So if being reacted with water, mag-dissociate yung hydrogen mo sa alcohol. So yung product mo is an alkoxide ion, RO negative. So for example, we have the phenol here. If yung hydrogen mo is mag-dissociate sa phenol, yung product is phenoxide ion, which is an alkoxide ion. So recall from your analytical chem. So the strength of any acid. So yung acid, it's also HA. So the strength of any acid in water, it can be expressed by the acidity constant or yung Ka mo. So if you have a smaller Ka value, and then yung pKa mo, yung pKa is the negative log of your Ka. So if small yung Ka mo, and then yung pKa mo is, meaning yung pKa mo is larger, di ba? So meaning less acidic siya. Meanwhile, if mataas yung Ka mo, meaning yung pKa mo is smaller naman, meaning, so acidic siya. Acidic yung compound mo. So here as shown in table 17.1, so simple alcohols like methanol, and then we have the ethanol. This is ethanol pa. Ethanol and then methanol. So they are as acidic as water. But yung alcohol na more highly substituted like tert-butyl alcohol, so more highly substituted siya. So meaning mas weaker acid siya. So the substituent groups, they have a significant effect on the acidity of your alcohol. So for example, you have 2,2,2-trifluoroethanol. So it has smaller pKa value. So mas strong acid siya compared sa water, ethanol, and methanol. And meanwhile, yung phenol mo naman and yung thiol mo or yung thiol is yung may sulfur na sulfur analogs of alcohol. So they are acidic than water. So therefore, yung effect ng alkyl substitution mo sa alcohol on alcohol acidity is primarily due to solvation of alkoxide ion. So, di ba, yung alkoxide mo is na-form pag yung alcohol mo is mag-react with water. So, if yung solvation of the alkoxide ion formed during acid dissociation, so if yung alkoxide ion mo is more readily um, solvated by water, so mas stable siya if may access yung if may access yung water mo with your alkoxide ion. So mas stable siya. So meaning mas mag-form yung product mo. And then yung acidity mo naman is greater. So meaning mas acid siya, stronger yung acidity niya sa parent alcohol. So for example, yung sa methanol. So this is methanol. So if yung methanol mo, if i-compare mo siya sa tert butyl mo, 'di ba mas accessible, mas sterically accessible yung methanol mo. So meaning mas easily solvated yung methanol mo with water. So if easily solvated with water siya, meaning mas stable siya. So meaning mas more yung formation niya sa product. So mas stronger acid siya compared sa tert butyl alcohol, which is sterically inaccessible and then less easily solvated, therefore less stabilized and weaker acid. So the effect is due primarily to the solvation of the alkoxide ion. So in summary, simple alcohols are about as acidic as water, then alkyl groups make an alcohol weaker acid. So the more easily the alkoxide ion is solvated by water, the more its formation is energetically favored. So steric effects are important for acidity. So for example, yung methoxide ion mo, this is from your methyl alcohol. So methoxide ion, mataas yung pKa niya, ay maliit yung pKa niya compared sa tert butoxide ion. Kasi sterically accessible siya, less hindered compared sa tert butoxide mo, more hindered siya. So meaning less accessible if mag-react yung water. So inductive effects, in which yung mechanism, di ba na-discuss na natin last meeting, inductive effects are also important in determining alcohol acidities. So, electron withdrawing halogen substituents, for instance, stabilize an alkoxide ion by spreading out the charge over the larger volume, thus making the alcohol more acidic. So, for example, let's compare the acidities of an ethanol. So this is ethanol. So ethanol has the pKa niya is 16, and then 2,2,2 trifluoroethanol, pKa niya is pKa ng 2,2,2 is mali dito. pKa is 12.43. And then yung tert butyl alcohol mo naman, pKa niya is 18. This is a nonafluoro tert butyl alcohol. Yes, this is not 2,2,2 trifluoroethanol. This is nonafluoro nonafluorotert butyl alcohol. That's why yung pKa niya is 5.4. So, mas maliit yung pKa niya dito kasi may electron withdrawing groups siya, yung mga fluorine. Pag may mga electron withdrawing siya, so meaning maliit yung pKa niya. So, if maliit yung pKa niya, mas strong acid siya. Okay, so because alcohols are weak acids, they don't react with weak bases, such as yung amines or bicarbonate ions. So, yung alcohol, they react with alkali metals and strong bases. So, for example, we have the sodium hydride, NaH, and then sodium amide, NH2, and then the Grignard reagent, RMGX. So the result is an alkoxide. This is alkoxide. So the alkoxides are themselves bases. So naging base na yung alcohol mo that are frequently used as reagent in organic chemistry. And they are named systematically by adding ate suffix to the name of the alcohol. So yung methanol maging methanolate. Here, sodium methanolate. And then yung tert butyl 2-methyl 2-propanol is maging potassium 2-methyl 2-propanolate. Yung ethanol mo is maging ethoxide or sodium ethanolate. And then yung cyclohexanol mo is maging bromomagnesium cyclohexanolate. So again, alcohols are weak acid and they do not react with weak bases. So they react with strong base, such as sodium hydride, sodium amide, and Grignard reagents. Okay, phenols are more acidic than alcohols, diba? Based on this table here. Phenol, they are more acidic than alcohol because the phenoxide anion is or resonance stabilized. So the substituted phenol can either be more acidic or less acidic than phenol itself, depending on whether the substituent, if my substituent groups ka sa phenol groups mo, it can either be acidic or less acidic, but it depends on the substituent mo. If yung substituent mo is electron withdrawing or electron donating. So remember electron donating and electron withdrawing, diba? So phenols with electron withdrawing substituent, they are more acidic because these substituents delocalize the negative charge. So, yung mga phenols na may electron donating naman substituent, less acidic siya because these substituent concentrate the charge. Again, phenols na may electron withdrawing substituent are more acidic. And yung phenols with an electron donating substituent less acidic. So for example here, nitro group, NO2. So acidifying effect of an electron withdrawing substituent is particularly noticeable in nitrophenols. So yung nitro group dito is electron withdrawing. And what are electron withdrawing groups? So 'di ba yung nasa last week natin na discussion, electron withdrawing substituents, they are also called as the activators. So another examples are yung if yung benzene mo is may halogen, sulfonic, cyano, carbonyl, nitro, NH3, COOH, or CHO. So, sila yung mga deactivators, di ba? Meaning, electron withdrawing sila. So, if electron withdrawing, more acidic. And if electron withdrawing or activators, they are less acidic. Okay, so now let's go to the preparation of alcohol. So how do you synthesize alcohol? So they can be prepared from many other kinds of compounds like alkenes, alkyl halides, and we have ketones, esters, and aldehydes. And then they can form or be transformed into an equally wide assortment of compounds. So for first one, let's gonna discuss about alcohols being prepared via hydration of alkenes. So there are two indirect methods used. So we have first the hydroboration. This is already discussed in our midterms, hydroboration oxidation. So the hydroboration oxidation, it yields, yung product niya is syn non-Markovnikov's hydration. Okay, so this is already a review from your previous term discussion. And then another one, yung another preparation by hydration of alkenes is the oxymercuration, demercuration. So yung product niya is Markovnikov's hydration. Okay, 1,2-diol also can be prepared by first is direct hydroxylation of an alkene with osmium tetroxide. Then it will be followed by reduction via NaHSO3 or by acid catalyzed hydrolysis of the epoxide group. And then the osmium tetroxide reaction, it occurs with syn stereochemistry, and it gives cis diol. So yung product niya is cis diol. And then another one is we have the epoxide opening. So it's it occurs with anti-stereochemistry. And then yung product niya naman is trans diol. So for seat work, kindly answer this for 20 minutes.